Welcome to ZK Vibes, your weekly dive straight into the fascinating world of zero-knowledge technology.
Great to be diving in.
Today, we're tackling a really crucial piece of the puzzle, making real-time proving accessible. Not just fast, but accessible.
Exactly.
Our source is a deep dive from RISC Zero, and they're outlining some pretty ambitious work they're doing in this area.
Yeah, it's all about generating these, incredibly complex zero-knowledge proofs fast enough to be useful right now. That's the key.
Right.
And why that's so vital, especially thinking about Ethereum's future. But maybe even more importantly, how RISC Zero is trying to make sure this isn't just tech for, giant corporations.
But something anyone can potentially participate in.
That's the idea.
Okay, so RSC Zero, they aren't just talking about faster proofs. They're actually building a real-time proving cluster and basically, waving a flag saying, hey, come build this with us. Mm-hmm. And they highlight that their ZKVM, that's the zero-knowledge virtual machine, kind of like a computer that can prove its own computations, is, they claim, the only high-performance one right now with a fully open-source GPU cluster setup.
Yeah, and that open source part feels like a really big deal here.
Why is that so significant, the open source angle?
Well, it's this commitment, right? Not just for the core tech, the ZKVM itself, but for all the infrastructure around it. Think of it like having the full blueprints for a car engine, not just the owner's manual.
Okay.
You can really understand it, tinker with it, improve it. That's what open source gives you: total transparency and the freedom for anyone to build on it or check it.
Right, no black boxes. And they've put some numbers out there too, haven't they? About what it takes to get involved.
They have. They're estimating the hardware cost at around $120,000.
Okay, $120K.
And they're projecting an end-to-end proof time, so from start to finish, of about 9.25 seconds.
Wow, okay. Under 10 seconds.
And they're presenting these as, achievable figures, not some far-off dream, but something doable with current tech.
And that $120K, I mean, it's obviously not pocket change, but compared to maybe developing custom chips, custom ASICs.
Exactly. That's often been the barrier, right?
Yeah.
These multi-million-dollar custom hardware projects. $120K, while still significant, puts it in a different league. More accessible.
So connecting this to Ethereum, then you mentioned the roadmap. How does this real-time proving fit in?
Well, the Ethereum Foundation, they have this vision, where proof generation becomes part of proposing new blocks on the chain.
Right inside the block proposal process.
Yeah, and that's where the real-time bit becomes absolutely critical. You've got roughly that 12-second slot to propose a block on Ethereum.
Okay.
So the proof generation has to fit within that window or close to it if you want ZK proofs integrated directly at layer 1.
Makes sense. If it takes longer than the slot, you miss your chance, basically. It creates a bottleneck. But the RISC Zero piece, it goes beyond just the speed. It raises this flag about centralization. Why is accessibility so critical here?
The worry is pretty straightforward, really. If the only way to generate proofs fast enough is with these super expensive, maybe proprietary multi-million-dollar setups,
then only a few players can afford to do it.
Exactly. Then the ability to actually participate in this core function of a future ZK-enabled Ethereum proposing blocks with proofs becomes really limited. And that creates a serious risk, right? Centralization risk. A few powerful entities controlling things, which kind of goes against the whole point of decentralization.
Yeah, the whole crypto ethos. So it's about keeping the playing field level, even with this advanced tech.
That seems to be the argument.
And this is where RISC Zero is making its specific bet, it sounds like. Emphasizing, again, that their ZKVM is the only one letting you run your own GPU clusters for this. And that everything, the circuits, the math underneath, the GPU code, the software to manage the cluster is all 100% open source.
Yeah, they're really hammering that point home. It feels like they're trying to remove every possible barrier to entry they can.
That open source part really is the linchpin, isn't it?
It seems like it. It means anyone can check the code, look for bugs, look for security issues, make sure there's nothing hidden.
Right.
It lets developers build on it, adapt it, without asking permission or paying license fees. And crucially, it lets, individuals or smaller groups set up their own proving systems.
Preventing that winner-take-all situation.
Hopefully. And the source material even points you to places where you can see their GPU acceleration working and get the info to set up your own multi-GPU rig.
Okay, so we get why speed matters for the roadmap and why accessibility matters for decentralization. But let's really dig into what this unlocks on Ethereum itself. What becomes possible if we have this real-time proving?
Well, one of the biggest things is the potential for massively increased gas limits.
Gas limits, okay. The cost of doing stuff on Ethereum.
Exactly. We could be talking like 100 to 1,000 times higher limits potentially.
Wow, 1000x.
How? It comes down to something called constant time proof verification. Basically, verifying the proof, checking that it's valid, is always fast and cheap for the network.
Okay.
It doesn't matter how much computation, how much heavy lifting went into creating the proof. Verifying the answer is quick.
So the network only cares about checking the final proof, which is always easy, regardless of the complex calculation behind it.
Precisely. So the network doesn't need to be so restrictive about how much computation you can do in the first place.
That is a huge potential jump in what you could run directly on-chain, or at least prove on-chain. What else? The source mentioned composability.
Yes, synchronous composability between rollups. This is a big one.
Rollups being the layer 2 scaling solutions, right? Like Optimism, Arbitrum, ZK rollup.
Exactly. Right now, often when they need to talk to each other, it's asynchronous. There are delays, messages back and forth. It's not seamless.
Right. It can be clunky.
Real-time proving could potentially allow these different rollups to interact, like instantly, synchronously.
So a transaction could maybe hop between different rollups, almost like they were all part of the same system.
That's the vision. It would be a massive improvement for interoperability, for building complex apps that span different layer 2s.
Okay, that sounds powerful. And the last point was about more secure light clients. How does that work?
So today, if you're running a light client, like a wallet on your phone, not a full Ethereum node, you're basically trusting the network validators to tell you the correct state of the chain.
You trust their signatures, essentially.
Yeah, you trust they're being honest, with real-time validity proofs generated for every block.
The light client could check the proof itself.
Exactly. Instead of just trusting the validator signatures, your light client could actually verify the proof that confirms the EVM state updates are correct.
So shifting from trust to cryptographic verification, even for light users.
That's the idea, a pretty fundamental shift in the security model. And again, this is something the Ethereum Foundation is actively pursuing in their roadmap.
Okay, so getting under that, say, 12-second proof time is like the entry ticket, the first step to unlock all this potential.
Right.
But as the source really stresses, that speed doesn't mean much for decentralization if only like 3 companies in the world can actually achieve it.
Precisely. That's the core message coming through from RSC0, I think.
Yeah.
For ZK Tech to really benefit Ethereum Layer 1.
Yeah.
Generating these proofs has to be accessible. It needs to be something many people can participate in as part of proposing blocks. Otherwise, you risk the tech that's meant to improve things actually leading to more centralization.
Which would be ironic, to say the least.
Definitely.
And RISC0's plan to make it accessible seems to boil down to those two things. That hardware cost projection, the 120K they call hardware you can actually buy, not some hypothetical $1 million rig, and making the whole stack, top to bottom, completely open source.
That really seems to be the strategy. Give people a realistic hardware target and give them all the software completely open so they can actually build it and run it themselves.
It's not just providing the tools, it's inviting the community to build the infrastructure together.
Yeah, empowering the community, fostering innovation, letting people build distributed proving networks. That seems to be the goal.
Okay, so let's try and wrap this up. Real-time proving, super important, maybe foundational for Ethereum's ZK future.
Absolutely.
It unlocks potentially huge scalability gains, better ways for different parts of the ecosystem to work together, and stronger security guarantees even for light users.
Right.
But this future is only really strong and resilient if generating those proofs is decentralized, if lots of people can do it.
Couldn't agree more. Accessibility is key.
And RIC0 is positioning themselves to deliver on both fronts. The speed with that projected, 9.25 second time?
Around 9.25 seconds, yeah.
And the accessibility through aiming for more affordable hardware and making everything open source.
Exactly. They're making a strong case that, a fast ZK future for Ethereum must also be a decentralized one. And they're offering a path to get there.
That's it for today's episode of ZK Vibes. We hope you found this discussion on real-time proving insightful and inspiring.
Yeah, it's definitely exciting stuff happening.
Until next time, keep vibing with ZK.
And maybe just a final thought to leave you with. As we think about making these powerful proving tools accessible, it really pushes us to consider the bigger picture. When new fundamental technologies like ZK emerge, who actually gets to wield them? Who participates in running the infrastructure? The answers to those questions will shape more than just the tech itself, something to ponder.